Imagine looking up at the night sky, feeling an overwhelming mix of wonder and dread as you learn that a massive asteroid, dubbed the City Killer, is hurtling toward our planet. In 2032, a celestial body of significant size might cross paths with Earth, potentially causing widespread devastation. Today, we delve into the mystery, science, and urgency surrounding this ominous threat. This is not science fiction. It is a factual, data-driven exploration underpinned by insights from NASA, ESA, and peer-reviewed research. Welcome to our comprehensive documentary on the potential impact of the City Killer asteroid. The study of near-Earth objects, NEOs, has evolved over the past few decades as astronomers have become increasingly aware of the potential threat posed by asteroids and comets. Near-Earth objects are celestial bodies whose orbits bring them close to Earth, sometimes within a few million miles. The City Killer asteroid, officially designated as 2023 QX17, a provisional designation used in preliminary reports, first came to the attention of astronomers during a routine survey of the sky conducted by telescopes at the European Space Agency, ESA, and NASA's Near-Earth Object Program. Early observations indicated that 2023 QX17 has a diameter estimated at roughly 1.2 kilometers, approximately 0.75 miles, placing it in the potentially hazardous asteroid classification. Based on its size and speed, if an impact were to occur, the consequences could be catastrophic, potentially leveling entire urban areas, a reality that justifies its ominous nickname, City Killer. Historical records remind us that Earth has experienced significant asteroid impacts in the past, such as the event that contributed to the extinction of the dinosaurs 66 million years ago. While the frequency of such large events is very low, the potential for severe damage makes tracking asteroids such as 2023 QX17 an absolute priority. The history of asteroid monitoring gets its start from missions like NASA's NEOWISE and ESA's Gaia Observatory. These programs have allowed a detailed cataloging of thousands of NEOs. As our technological capabilities have improved, so too has our ability to predict complex orbital behavior, setting the stage for the discovery and analysis of dangerous objects like 2023 QX17. To understand the threat posed by the City Killer asteroid, we must examine its trajectory through space. Recent observations combined with astrodynamic simulations suggest that 2023 QX17 follows an elliptical orbit around the Sun. Calculations derived from data provided by NASA's Jet Propulsion Laboratory, JPL, and ESA's tracking stations show that its orbit brings it within a close range of Earth's path every few decades. According to the latest published findings, 2023 QX17 has an estimated impact probability of approximately 0.03%. While this seems like a small chance, the consequences of an impact involving an object of over a kilometer in size are too severe to dismiss without rigorous study and precautionary measures. To put this in perspective, NASA's Planetary Defense Coordination Office uses similar probability estimates to assess threats and plan potential mitigation strategies. The asteroid's current trajectory indicates it will have a relatively near pass in 2032. Orbital mechanics, largely determined by gravitational influences from planetary bodies, particularly Jupiter and Earth, and non-gravitational effects like the Yarkovsky effect, a force acting on a rotating body in space due to the anisotropic emission of thermal photons, contribute complex variables to its motion over time. Researchers rely on these models to simulate future positions of 2023 QX17 accurately. And while a 2032 impact remains a possibility, The dynamic nature of celestial mechanics means continuous observation is needed. Scientific studies published in peer-reviewed journals such as Icarus and Astronomy and Astrophysics have detailed the methods used to calculate the asteroid's orbital parameters. These include determining its semi-major axis, eccentricity, and orbital period. Through these parameters, researchers have been able to estimate the minimum distance the 2023 QX-17 will approach Earth during its flybys. NASA reports that while the chances remain low in numerical terms, the uncertainty margins in long-term predictions underscore the need for vigilance. Should 2023 QX-17, the city killer, collide with Earth in 2032, the impact would have catastrophic consequences, particularly if it were to strike a densely populated urban region. Experts in planetary science and disaster management have long modeled such scenarios. An asteroid impact by an object of this size is estimated to release energy equivalent to several hundred megatons of TNT, enough to create widespread destruction over a large area. In the immediate aftermath of an impact, the release of energy would result in a massive shockwave and intense heat, vaporizing everything within a significant radius around the point of impact. Debris ejected from the collision would rain down on a wide area, potentially igniting fires and causing secondary explosions. Dust, soot, and aerosols could be thrown into the atmosphere, blocking sunlight for extended periods and disrupting global climate patterns. A phenomenon similar to the hypothesized impact winter that some scientists believe contributed to past mass extinctions. Atmospheric effects from a major impact might include severe weather anomalies, acid rain, and long-lasting disruption of ecosystems. In urban centers, the infrastructure damage would be compounded by the highly concentrated population, potentially leading to a significant loss of life and a humanitarian crisis on a scale we have never seen. NASA's studies on impact hazards, referred to NASA's Near-Earth Object Program updates and related publications, emphasize that while global consequences are a possibility, the worst effects are generally localized. However, in our interconnected and highly urbanized world, the ripple effects of a catastrophic event could destabilize economies, supply chains, and governmental systems globally. The potential threat of an asteroid impact is not a scenario without options. Across the globe, space agencies and defense organizations are working together on strategies to detect, characterize, and, if necessary, avert disaster. NASA's Planetary Defense Coordination Office, ESA's Space Situational Awareness Program, and various international consortia continuously share information to refine predictive models and develop mitigation strategies. One of the primary mitigation methods discussed in the scientific community involves kinetic impactors. A kinetic impactor is a spacecraft designed to collide with an asteroid at high velocity to alter its course. NASA's DART, Double Asteroid Redirection Test mission, which successfully demonstrated the feasibility of this approach on a smaller asteroid, is a pioneering example of such technology. While DART focused on a relatively small asteroid, the principles involved are scalable. In the event of a significant imminent threat from an asteroid like 2023 QX-17, an international coalition could potentially deploy a series of kinetic impactors, possibly supplemented by other methods such as gravity tractors or even nuclear options as a last resort. Another vital area of research is the precision tracking and observation of near-Earth objects. The more accurately we can predict the future position of an asteroid, the more time we have to implement defensive measures. This has led to proposals to improve our network of Earth-based and space-based telescopes. Initiatives like NASA's NEOCAM, Near-Earth Object Camera, are designed to enhance our ability to detect and track threatening objects. In addition to technological solutions, global response strategies are being developed and regularly updated under the auspices of the United Nations Office for Outer Space Affairs, UNOOSA. These strategies emphasize the need for international cooperation, resource sharing, and clear communication during potential impact crises. According to policy documents and scientific workshops, robust mitigation planning not only focuses on diversion, but also on post-impact relief and recovery planning, should deflection efforts not fully succeed. It is important to note that the scientific community remains cautious. Every mitigation strategy is subjected to rigorous simulations and testing, often published in journals such as Nature Astronomy and Advances in Space Research. These studies highlight that while there is hope in technology and planning, time is of the essence, because the longer an asteroid is tracked without intervention, the higher the stakes. If you found this documentary insightful and thought-provoking, please subscribe to our channel and hit the notification bell for more space science updates and documentaries. Share this video with friends and family to spread awareness about the efforts being made in planetary defense. Follow official agencies like NASA and ESA on their social media platforms and check out their websites for the latest research and updates. Your engagement helps drive public interest and support for the technologies and international collaborations that might one day save our planet from a catastrophic event. Stay curious, stay informed, and remember, the pursuit of knowledge is our best defense against the unknown. Thank you for joining us on this journey through the cosmos, where knowledge meets urgency and science becomes our shield. Together, we can be vigilant and prepared, ready to face the challenges that lie ahead in our exploration of the universe.